to join us. I know it's a tough week, the holiday week. I'm also pleased to announce that we have Steve Disher with us. He's with LearnMicroTik.com, and he's a very busy man. He's tough to pin down to be able to get him. But Steve, I think Steve is also, you're a MikroTik certified trainer and a consultant. He teaches classes, I think, all over the U.S. and abroad too. If I'm not mistaken, right, Steve?
That's correct.
Yeah, and he's I think he's owned a WISP about the last 5 years. You know, he's a busy man. I think you just finished your first book. I think with RouterOS by example. I think that didn't you just complete that too?
I did.
Yeah, I think, and he might, I don't know, he might talk a little bit about that when we get into the webinar. But it's a great book. I think he uses it as it's even a textbook used for the MikroTik Certified Network Association, and he uses it as a textbook. So. I think I'll turn it over to you, Steve. I think you're going to talk about stateful firewalls with MikroTik RouterOS. So let me turn it over to Steve, and thank you very much again for your time. I know you're a busy man, and I really look forward to all the information you're going to share with us. So go ahead, Steve, take it over.
Well, good. I appreciate you having me here today. Scott, you told me we have about 30 minutes for the webinar today, and so we'll move fairly quickly through the slides. What I wanted to do today was to give you a little bit of an overview of some of the newer products in the MikroTik line, and then to actually give all of our attendees here today some free training on MikroTik RouterOS. So we'll go ahead and get started now.
Wow, that's great, Steve. One quick second, everybody. I know you're probably gonna have some questions because there's gonna be a lot of good information that Steve's throwing at you. So that in the questions pane, you can definitely just type the questions in there, and just to keep it moving along, we'll ask the questions at the end of the presentation. I'll ask Steve the questions, and then he'll be able to answer them for you. Sorry to interrupt you again there, Steve, but go at it. Thank you.
Yeah, no problem. So a little bit about me, and Scott's already kind of set me up pretty well, and that is that I'm a MikroTik certified trainer and a consultant. So what I do is I put on classes for people that want to learn about MikroTik RouterOS. RouterOS is a great and powerful router operating system, and unlike a lot of the competitors that are very simplistic in nature, it's not one of those things that you just pick up and you start using and feel like you've mastered it and have confidence. Training and some time spent learning the operating system really pays off and allows you to do some very powerful things with it. So I saw a bit of a lack in the market for a book that would help people that wanted to learn the product, and so I just finished a book. It's called RouterOS by Example. And we'll give you some details later on in the webinar about how you can get the book if you're interested. The book is about a little over 300 pages long. There's about 100 examples in there that take you step by step through the operating system. And if you want more information, you can look on my website at learnmikrotik.com/book and learn all about it there. So today we're going to start out by talking about the MikroTik product line, and MikroTik has really been spending at least the last 2 to 3 years getting very intense in the area of product development. And because of that, the product has really increased the number of products that are out there, and sometimes the model numbers and specifications get a little bit confusing. But what I want to do today is kind of show you top level how the products are laid out, and then show you some of the what I call the hotter products that they've got out, the newest stuff that really outperforms everything that's really been built so far. So, you know, if you want to just take a broad brush and paint down the center of the product line, what you'll find is that all of the MikroTik products really fall into 2 areas. One is what we call integrated solutions, and the other is router boards. So starting off with integrated solutions, integrated means that the product comes pretty much ready to go with all the accessories that you need. What I'm talking about here is not only the heart of the system, the router board, but also the case, power supply, or power over Ethernet injector if it's an outdoor product. On the slide you see right now, there's 2 of the products that are more the common use products. One is the RouterBoard 750 series, which is an indoor router. It's a 5-port Ethernet router, and these guys are low cost. They're less than $50, and they're really powerful and do a great job for indoor small office, home office, router, or firewall application. And then the other device that I'm showing here, go back to that slide, is the SXT, which is a point-to-point or point-to-multipoint bridge wireless solution. So these are the integrated solutions. You get everything that you need, and you're ready to get up and operating. The other side of the house is what we call the router boards, which are just basically a bare bones board that can either be put into an indoor case or an outdoor case. And these devices come with either a slot, a mini PCI slot, to which you can add a wireless adapter, or some like the new 711 series have integrated wireless on the board itself. So very low cost, a lot of versatility in that you can supply your own case, you can buy one of the many cases that are out there on the market, and these can either be indoor devices or outdoor devices depending on what you're trying to build. So with an assortment of these boards and the radio modules that go with them, you have a lot of versatility in what you're able to provide as a solution for a customer. So talk kind of in a broad way about features of RouterOS, and it's a question I'm often asked, and that is, which product do I need to get a certain feature? And the answer is pretty simple, and that is that pretty much across the board you get all of the features that are available within RouterOS. The only way they really differentiate between the different levels of features is through the licensing. So if you're buying a board or a device that's considered to be a client device, typically in a wireless world this would be a device operating in station mode or station WDS mode or a bridge mode. That device is typically going to have a level 3 license. Now the only real limitation that level 3 license puts on it is that it can't be an access point mode. But you still have access to all of the features of RouterOS. So all of the complex routing functions like MPLS, VPLS, OSPF, it's all there in a device that costs less than $50. So as far as features are concerned, all of the features are available across the entire product line with very minor exceptions. And typically those exceptions are in the number of tunnels that the device will support or the number of clients it will support simultaneously. As far as the feature set is concerned, all of the MikroTik RouterOS products have wireless capability in the form of 802.11 A, B, G, or N. A few of the Ethernet-only boards do not have the ability to support a wireless device internally, although if they have a USB port, then you can use a USB wireless adapter with that device. They will all operate in station mode, and then as long as the device has at least a level 4 license, it can be operated in point-to-multipoint or access point mode. WDS, wireless, meshing, bridging, all of that is contained in that feature set. We spoke briefly about some of the routing protocols that are supported, including BGP, OSPF, MPLS, and VPLS. And then finally, the last feature that is available across all of the licenses that are available is the Stateful Firewalls. So now what I call the 3 hottest new products from MikroTik. And the first one is one we've been waiting for quite some time. It's the RB1100 AH-X2. Now, the 1100 has been around for a while, and you basically what you get with that is a rack mount device with a ton of gigabit Ethernet ports across the front, so 11 to be exact. Two of the ports can actually be in bypass mode, so if the device were to have a mechanical or electronic failure, you can switch the switch and bypass the device. So in the case of a bridging firewall, this would be a nice feature to have. The AH means that this device has extra RAM and extra CPU speed, and then the X2 means that it is a dual-core device. So this is the most powerful router that MikroTik has put out so far, and these guys are just flying off the shelves as fast as the vendors can get them there because they're so popular and a lot of pent-up demand for this particular device. So I would say this is probably the hottest product that MikroTik has come out with in 2011 so far. The next product that I really like and we've been waiting for quite some time is the RB751U-2HND, kind of a long product number there. But what this is telling you is this is a 750 series router, so it's their typical 750 Ethernet router. But to that, they have added 802.11 in wireless. And it's not just single chain, it's dual chain wireless. So we've got a lot of wireless speed in a very small form factor, low cost device, very high performance. And the U in the model name also designates that it has USB capability. So this is really a great SOHO device, small office, home office, or even a medium-sized office with a lot of capability. One thing it also has that is new to the line, and that is an external MMCX antenna connector. So even though it has internal antennas, you can also add an external antenna to this device. And the third device that I want to talk about is the RB750UP. This is very similar to the RB750 that we've all come to know and love and use as a staple in our solutions toolbox, but they've added something to it, and that is power over Ethernet capability. So not only can you power this particular router with PoE, it also will output PoE. So ports 2 through 5 put out whatever voltage you supply to the device. So you put 24 volts into it, they send 24 volts out. So this is really a product we've been waiting on for quite some time, and it will allow a lot of versatility and the ability to get our costs way down when providing solutions for our customers. So not only is it a 5-port Ethernet router, it also has a USB 2.0 port on the side and 4 ports that will supply power over Ethernet. So now, kind of wrapping up the 3 hottest new products from MikroTik and Router Board, I want to give you a little bit of training today about firewalls. And this is probably one of the most common questions I'm asked, and that is, how do I set up a firewall within RouterOS? Because it's not one of those products that just has buttons that you check and suddenly you have features. It is so highly configurable that in order to make the device a firewall, you need to actually construct a firewall using multiple firewall rules. And so because of that, it can get very perplexing. You know, which rules do I need? Which rules do I not need? How do I do this? So I want to give you a mini how-to today, and by following this step by step, and we will make the presentation available to you for download, you can create a stateful firewall that will do a really good job in a SOHO environment. So I want to lay some groundwork here, and the lag on the slides sometimes gets me a bit confused, but first of all, I'll tell you what a stateful firewall is. And a stateful firewall is a type of firewall that's able to track the state and the attributes of the connections passing through it or going to it. And this is juxtaposed with a stateless firewall, which is commonly known as a packet filter, and it simply makes go or no-go decisions for packets based on source and destination. And stateless firewalls have no knowledge about preceding packets. They are only living for the moment. Packet comes in, they make a decision, and they wait for the next packet. A stateful firewall, on the other hand, knows about all the traffic that has previously passed through it. And so that really makes it a better option. Stateless firewalls are more vulnerable to spoofing attacks. They don't play well with certain protocols like FTP. And they're basically just brute firewall filters. And they have very little granularity. A stateful firewall, on the other hand, originally credited to a company called Checkpoint Solutions in the mid-1990s. And it can store a significant amount of information about the packets passing through the firewall. And stateful firewalls give you a high level of granularity, and they are highly efficient. And MikroTik RouterOS has the ability to create a stateful firewall, and that's why it's such a powerful firewall in such a small, low-cost package. So what I'm going to talk to you today about in our mini how-to is the elements that are required to create a firewall. Now, first of all, I need you to understand 4 different things. One is connections, how connections work. The second is chains, that is how these rules are organized. The third is where you get to the packet matchers within RouterOS. And then fourthly, we will create a simple stateful firewall in RouterOS. And this is something you can use at home or you can use in a client's office and provide a very powerful solution for them. So starting off talking about connections, there are 4 elements to an IP packet that are important to us as far as firewalls today. First is the source address. That is where the packet came from. And every IP packet has this information embedded into the header of the packet, where the packet came from. The second is the source port, and that is the sending host. What port was assigned to that packet from the host that sent the packet? The third piece of information is the destination address, where this packet is going to, and the fourth piece of information is the destination port. So first of all, source address. That is the IP of the computer that is trying to get to the internet in the case of our example here. So this could be your laptop trying to get to Google. So the source IP of that packet is your laptop. Now, the source address of the packet can often get changed by a firewall if it's doing something called network address translation. But for the purposes of our arguments now, we're going to just consider the source IP address of the packet to be the host that's sending the packet. The second thing is the destination address. That is the IP that the packet is being sent to. So in the case of typing Google in your web browser, the destination IP would be the destination IP of Google's website. The other 2 pieces of information are the source port and the destination port. Source port is the one coming from the computer trying to get to the internet. The destination port is the port the packet is being sent to. So these 4 pieces of information will help us to define connections that are being made through our firewall. And each connection will consider basically a client trying to get to some host outside our firewall. In addition to those 4 pieces of information, that is source IP, source port, destination IP, and destination port, there's some additional information that the firewall can track, and that is the state of a connection. So every time a connection passes through our firewall, it's going to be in one of 4 states. Those states are new, that is, it's a connection that has never been seen before. The second is established, meaning that it's already been a new connection. Now all the packets that follow in that connection are considered established. The third is related. And this is really kind of particular to certain types of protocols. For instance, the FTP protocol will create related connections. And then the fourth type of connection is the invalid connection. Invalid connections are never anything beneficial. So for purposes of our firewall, we're always going to drop invalid connections. Okay? So again, new. That means it's the first time this connection has ever been seen. And by connection, I mean a connection combination. This combination of port, addresses, it's the first time it's ever been seen in this particular scenario. Second is established. It's part of a known connection. Related, part of a known connection combination. And invalid. So here's a graphic that kind of shows you visually what connections look like when they pass through a firewall. And hopefully by moving my mouse pointer here, I'll just give you some idea of orientation where we are. But in this particular graphic, we've got a firewall, and these are 5 different types of connections that are passing through the firewall. And what you'll see is that the first time a connection is seen by the firewall, that particular combination of ports and IP addresses, that is considered a new connection. And then every single packet that follows that is considered an established connection. This second line, this black packet, is an invalid packet, which we're going to drop. And so following an invalid packet, the next connection would be a new connection with established following, and so on. So this is kind of the sequence that connections go through. They start out new, and then they go to established. And in this particular scenario, we have a related connection, which is part of this established connection. So summarizing connections for you now, first of all, the connection combination. That is the 4 pieces of information about the connection. That is the source address, the destination address, source port, and destination port. The second important thing to know about connections is that they go through one of 4 states, either new, established, related, or invalid. So the next thing we're going to talk about is chains, and that is the way that firewall rules are organized or constructed in RouterOS. The chains, quite simply, are the locations in the router where the packets are seen by the firewall. So there's 3 default chains: input chain, a forward chain, and an output chain. The input chain, that is packets that are going to the firewall device itself. So if you put rules in the input chain, those rules will protect the router itself. The second chain is the forward chain, and that is packets that are going through the firewall. So if we have clients behind a firewall, any packets that are going to those clients, those are going to go through the forward chain. So this is where we're going to put rules that protect our customers or our computers on our local area network. And the last chain is the output chain, which seldom are used in typical firewall rules that we create in most of our firewalls. These are really specialized rules that go in the output chain. So these are packets that are leaving the router, generated by the router itself. So for instance, if you're logged into the router and you ping some host on the internet, that is going to pass through the output chain. So for purposes of today's discussion, the 2 chain and the 3 chain are the ones we're going to talk about. Again, the input chain protects the router, the forward chain protects the clients, and the output chain is only for packets that are departing the router, that are generated by the router. Firewall rules operate on an if-then principle, and RouterOS uses something called packet matchers to identify the packets. That's the if part of the if-then. Secondly, there's an action tab on every rule that performs some action on the packets that match the if principle. So it's if-then. If a packet matches this criteria, then we're going to perform some function on the packet. So where do we get to firewall rules in RouterOS? Well, it's done under IP Firewall, and once you get there, there's a tab called Filter Rules. And by hitting the plus sign here, we can create rules that will allow us to perform certain firewall functions on RouterOS. So I've created a new rule now, and this general tab is what I call the packet matcher. The more information you fill out here, the more restrictive the rule is. Anything that you don't fill out is considered to be a wildcard. So in this particular scenario, we've selected the input chain to the router. So if you remember from the previous slide, input chain rules protect the router itself. As far as the source address, I have put in a network address of 192.168.1.0/24. And so this particular rule is going to match all traffic that is coming from, in this case, our local area network. So anything .1 through .254 is going to match this particular packet matcher. Now you notice that I haven't filled in any other criteria, so that means I'm going to match all destination addresses, I'm going to match all protocols, and so on, all interfaces, etc. So this is going to be a not very restrictive rule. It's only going to be looking at traffic coming from our local area network, but I'm not going to make any restrictions about protocol or ports. The second important tab on a new firewall rule is the action tab. And remember we said it's an if-then principle. So this is the then part. For purposes of our discussion today, we're only going to select one of 2 actions. We're either going to accept packets or we're going to drop packets. So those are the only 2 actions we're going to deal with today. So summarizing the packet matchers now. The general tab is where we specify one or many criteria that we want the packets to match. The action tab is where we perform some action on the packet if it matches. So now we're going to go step by step, and we're going to create a simple stateful firewall in RouterOS, and that is a firewall that will pay attention to the state of connections going through the firewall. So we're going to create some rules in the input chain first of all. We're going to create 4 different rules. And if you remember back, the input chain protects the router itself. So we're going to restrict who can manage this router. or who can try and access some service on this router. So the first rule is going to drop invalid connections, because we said before that invalid connections are never helpful. Okay, it's either a malformed piece of software that's producing invalid packets or possibly some kind of hacking attempt. The second rule will allow the router to be managed from our local area network IP subnet only. So anybody who's in the 192.168.1 network will be able to get into this router and manage it. The third rule will allow connections back to our router if we initiate a connection. So what I mean by that is if the router tries to ping some host on the internet, we want that ping to get back to us. So we have to have a rule to allow that. And then the last rule is called the drop rule. It drops all other packets to the router. So if you'll notice here, we have three rules that are trying to match certain types of packets, and then a fourth one that just drops everything else. So this is a very typical way to create a firewall. So now let's look at these four rules. Here's the first rule. So we're going to match the chain input here. So this is any packets going to the router itself. And if you'll notice, we have selected a connection state of invalid. So any invalid connections to this router, the action is going to be to drop. So we're going to get those out of the way just right off the bat. The second rule we're going to create is also on the input chain, but now we're going to say any packets coming from our local area network of 192.168.1.0/24, we will accept those packets. So that will allow anyone on our local area network to manage this router, to use this router for DNS resolution, and so on. The third rule, also on the input chain, is going to allow established connections. So if we try to, let's say, ping a host on the internet, that is going to initiate a new connection, which we're not restricting right now. The response is going to be part of an established connection, so this will allow the response to come back to this router. And the fourth rule is going to be drop everything else going to the router. So with these four rules, we have effectively protected this router from attacks, and we're only allowing it to be managed from the local area network. The next series of rules we're going to do will be in the forward chain. If you remember what we said earlier, the forward chain protects the clients behind the firewall. So with this time, we're going to make 5 rules. The first one will drop invalid connections, just like we did on the input chain. The second one will allow new connections if they are originated from our local area network, meaning if someone on our network wants to pop mail or browse the web, we'll allow that new connection to take place. The third rule will allow related connections. The fourth rule will allow established connections, and then we're going to drop everything else. So with this particular set of rules, our customers on our local area network can pretty much do anything they want to do on the internet, but hosts on the internet cannot get back through the router to try and attack our local area network. So very simplistic but effective firewall. So the first rule will be on the forward chain, and we're going to drop invalid connections. Simple rule, just like we did on the input chain, except now we're doing it on the forward chain. The second rule, also on the forward chain, will look at any traffic coming from our local area network, 192.168.1.0/24, with a connection state of new, and it will accept that through the firewall. So this will allow hosts on our internet, on our local net, to be able to get to the internet. The third rule in the forward chain, again, allows established connections. The fourth rule allows related connections. And as you might be able to guess, the last rule is a drop rule. It means drop everything else going through the firewall. So to summarize firewall rules, first of all, we always want to allow what is desired to take place on the input chain. And then we'll drop everything else on the input chain. We'll then do the same thing on the forward chain, allow the desired connection states that we want to allow, and then drop everything else. So some common errors that I see people make with firewalls. First of all, rule order is vitally important. You must have all of your accept rules before your drop rule, or you could actually lose your connection to the router itself, making it a little bit difficult to get back in and fix your problem. So always add your drop rule at the end. You might want to start off with the rule disabled until you're comfortable, you got your rules correct, and then enable the drop rule. Second, you want to work in something called safe mode. If you're not familiar with that, you can look it up on the MikroTik wiki in the manual. Safe mode will allow you to get booted out of the router if you make a mistake and then get back in, because when you're in safe mode, it doesn't save your changes. So if you're exited out of Winbox, the application GUI, all of the changes that you made get rolled back to where you were when you started safe mode. So use safe mode. When you're comfortable that you've made good changes, exit save mode. That'll save your changes, then go back into safe mode. And the third common error is don't try and get too complex. Start off simple. The 10 rules I just gave you will give you a fully functioning firewall. It's really all you need. If you want to add more bells and whistles later, then you can do that. Next, if you use the examples that I gave you today verbatim, don't forget to put your IP subnet in those rules, because there's one rule that allows new connections from the local area network. I'm using 192.168.1.0. Make sure you have your subnet there. If it's the same, great. If it's different, you'll need to change that. Next, use comments in your rules. There's a little yellow sticky note in Winbox on each rule, and that will allow you to put a comment on that rule. And that will allow you to go back later and remember why you created that rule in the first place, or exactly what it does. Next thing I would add as a suggestion, not really an error, but make your rules more extensible by using something called address lists. Again, those are covered in class, they're covered in my book, they're covered on the wiki, a number of places. Address lists allow one rule to be applied to many different addresses, and they work really well. And then the last thing, make your firewall more intelligent by using some of the intelligent actions that are built into RouterOS, like add source IP to an address list, or add destination IP to an address list. A little more complex subjects, but they allow you to make the firewall very intelligent. And it's really an awesome feature that RouterOS has. So before we get to questions, a couple of pieces of information for you. First of all, if you're interested in my book, get it at learnmikrotik.com/book. Also at learnmikrotik.com on the home page in the lower right-hand corner is today's presentation you can download, or you can also email Scott at Microcom, and he can provide the presentation for you. Or if you're interested in attending a class, I've got the class schedule on my webpage, learnmikrotik.com as well. So Scott, apologize for so much information in such a condensed period of time, but hopefully our listeners today, or the attendees on the webinar, can go back and download the presentation and then walk through it a little bit slower pace and get some good free training out of it.
Oh no, Steve, this is great. Yeah, you're right. It was a bunch of information, and also what we're going to be able to do is we've recorded this webinar, so such good information, and we're going to be able to post it on our YouTube page too, hopefully later today. So if anybody's able to miss it, they can go back and take it at their own time and digest all the information Steve just gave, which is great. And like Steve mentioned, please you can visit his website to get any information, to get your hands on that book. I know those things have been selling pretty quick, Steve. So I mean, that book is a great asset to help anybody out that's doing anything with the routers. Let's see. I don't really have any questions right now, Steve. I guess you covered a lot of stuff. It's pretty blank. If anybody has any questions they'd like to ask, that'd be great.
Maybe I put them all to sleep. I don't know.
No, you didn't do that. But if anybody has any questions, or if they miss anything, they could email me at directly at Microcom at sales@microcomtech.com, and if there's anything that we can't answer, we'll definitely forward those questions along to Steve, and Steve will be able to answer those, and he'll get back to you. But again, great webinar, Steve. Thank you very much, and I don't have anything else to add except to have a great holiday, everybody.
All right, thanks
Thank you very much, Steve.
me. You bet.
No problem. Thank you very much. Have a great holiday. Thank you.
Same to you.
Bye-bye. Bye-bye.